think some of you had class, so you left, so I stopped just here. I didn't actually do the questions. The question I can korbo. So in a Kore, we'll move on to the next part of our topic. Our aim is to do as much as possible from resistance. Like what is resistance? What is Ohm's law? Thermistors, LDRs, why their behaviors as what they happen to happen. So we type it cover korbo, but it get to Kore. Okay, so find the PD for normally are Beshikuri. Beshikuri, I'll give you more of them, O levels, but I cannot tell, just go through a few of them, okay? So find VAE, find VBC, find VFE, and find VBF, find VA, G, and one more, find VCG. Right, so last class, if you missed the class towards the end, I taught you the concept of using a voltmeter, okay? So to use a voltmeter, what you need to do is you take one of the terminals of the voltmeter and you connect it somewhere. You take the other terminal of the voltmeter and you connect it somewhere else, right? And what that results in is something that we refer as potential difference. Okay, so potential difference our voltmeter screen show korbe. Now, what I want you to find out is VAE. So when they say AE, it's basically the first wire is at A and the second wire is at E. That's what VAE means. So if I connect my voltmeter terminals like this, right, what would the reading be? So all rest of the questions are actually the same. O levels, when we did potential difference, I did this, but the A levels, it's more important. Thus I'm going through this one more time, but I don't want to spend too much time here. So I'll give you like 5 minutes maximum. Tell me the answers. Okay, it's not that difficult. It's not A level stuff. So I hope you can do it faster. The mock বলছিলাম মনে হচ্ছে 29 but 28 30 এরকম কিছু when you tell your mock was. Yeah, so I might shift it a little bit because আমার হচ্ছে our charter class likely to wrap up electricity, right? So I want to finish electricity and then take the mock because mock is an hour. So before February starts, I want to wrap up electricity. The particle physics I will did like one class if I want to do like one extra class. Or even qualify was not a big problem. So yeah, your mock might be a little late, like four and something, whatever. Let's let you know. Also, I really want to do this as a previous mock for next mock. So if I can take like a separate class for that. Right. So VAE, do you know what you need to find in order to find the answer? Do you get current? Okay. But current you're going to keep it of it. Do you find voltage? Okay. Try to answer this question. Do you find potential difference? Do we find voltage? Do we find EMF? Do we find the PD across the circuit? Or do we find potential? Potential. What's potential? Yes, we find potential. So basically, you need to find the energy that the electron carries at these locations. And then if you know the values of the energy at these locations, what can you find then? The difference wherever you want. And what is that difference known as? Potential difference. Okay, so I'm like first potential বের করতে হবে. Now potential বের করার জন্য there are many different ways out there. O levels একটা করে আসছি আমরা, তার জন্য I won't be teaching you anything new here. O levels একটাই follow করি, which is you find current in the circuit and V equals to IR করে বের করা যায়. Okay, so কেউ কি বের করতে পারছো AE কত? 40. AE? No. Why should be 0?
Because it's connected in
different branches. That doesn't make it 0. As long as there's a difference in two parts, there will be current flowing here. It would have been 0 if it was AD. Yeah, AD would be 0. Then AE can't be 0. Okay. You have a minute left, so see if you can get the answer. I'll call it. AE is 60. 60, Ashikar? 60, right? Yeah, I think AE is 60 there. Achikuri, I can't really invest a lot of time here, unfortunately. So shall I to screen that ki korte hobe? First, you need to find the current in the two branches. Let me teach you the process. It's possible that you forgot what happened 8 months ago. So how to find the current in the upper branch there? What formula do I use? V equals to IR. V equals to IR is known as the what law? Ohm's law, right? Ohm's law representation of mathematical representation is V equals to IR. So can you tell me what is the voltage in the upper branch here? The whole branch, 100, right? So 100, current আমরা জানি না. What's the total resistance there? 50, right? So that means the current in this branch, the upper branch, what is the current? 2 ampere. So এখানে 2 ampere current আছে. We need that, okay? So এটা হয়ে গেল. এখন আমরা নিচের ব্রাঞ্চটা বের করব. নিচের ব্রাঞ্চে হচ্ছে again V equals to IR. The voltage is 100 volts. The current is unknown. The resistance of the lower branch is how much? 100. So how much is the current here? 1 ampere. So the current is 1 ampere at the lower branch. Do you understand? Okay, right. এখন কেমনে potential বের করা যায়? Let me explain. So listen to this very carefully. This will come back, right, many times. Sometimes to haunt you. Okay, because এটা যদি না পড়ো দেখবা কোশ্চেনে কিছু বুঝবে না. So be very careful about potential, because আমরা একটা টপিক করব eventually called potential dividers. And ওই টপিকের মেইন এইমটা হচ্ছে এই জিনিসটাই করা. Okay, so ওটার জন্য বিল্ড আপ করতেছি. So what you need to do here is এতে কতটুক voltage আসে ওটা আমাদেরকে বের করতে হবে. So I talked about this the other day, that the charge comes here. It starts off with how much energy? 100, right? It goes like that, it goes like that, it goes like that, and একটা পাশে চলে গেল, and it's now here. Did it use any energy yet? No, right? So what would the voltage here also be? 100 volts, right? এখন এই particular componentটা কিছু voltage use করবে, and ওটা বের করার জন্য formula again is what? V equals to IR. So আমি যদি এখানে V equals to IR use করি, I know my current, right, which is 2 ampere. So V equals to IR, 2 into 40. How much is that? 80. So এখানে কি হবে? 80 volt use up হয়ে যাবে. And once 80 is used up and you come to this point, the charge that comes to this point, 80 কিন্তু lose করে ফেলছে already. How much will be left? 20. Just 20, right? Just 20. So এখানে 20 volts থাকবে. এই 100 volt যেটা এখানে and a 20 volt এখানে, these are called what of the circuit? Potentials, okay? And then 20 টা এখানে, and then we saw this before, যে সব use up হয়ে যায়, তুমি naturally দেখবা এখানে 20 use হবে. দেখো কেমনে? 2 into 10 is how much? 20 volts. V equals to IR যদি করি. So if all the 20 is used up, when you reach at the end of your branch, how much should the potential be? 0. এটা আমি বলছিলাম তোমাদেরকে, I'll try to give you an analogy of this. আজকে বুঝাবো কেন potential 0 হয়ে যায় by the time you reach the other end. Okay. Anyways, আমাদের উপরে potential গুলো বের করা হয়ে গেছে. Similarly, I'll find the potential at the bottom as well. So can you tell me what's the potential at D? 100, correct. What's the potential at E? তোমরা একটু try করো এটা. What's the potential at E? 60, right? কেন 60? Because এখানে যদি আমরা ম্যাথ করি V equals to IR, আমরা বের করবো যে this particular resistor takes how much voltage? 40. So 100 থেকে 40 চলে গেলে how much is left? 60, right? So এই যে এখানকার potential হচ্ছে 60 volts. তারপরে পরেরটার থেকেও 40 চলে যাবে. So how much will be the potential at this location? 20. তারপরটা থেকে 20 চলে যাবে. How much is the potential at the end? 0. If you can manage to find these values, right? Next is like the most simplest question out there. Jar physics নাই, jar grade 6 এর math knowledge আছে সেই পারবে এটা. Okay, so tell me what's the potential between A, মানে হচ্ছে A তে যে চার্জটা আর E তে যে চার্জটা ওদের ডিফারেন্স কত হবে? এটা 100, এটা 60, right? What's the potential difference? 40 volts. Okay, so 40 volts হবে এখানে. বুঝছো কেন? Because one of the charges enters and has 100, the other has how much? 60. So what's the difference? 40. Can you tell me what's BC? 20 volts, right? Correct. What is FE? Yeah, FE টা negative কেন হবে? Because তোমার first wire টা এখানে, which is at what? 20, and your second wire is there, which is at what? 60. তাহলে আমার কিন্তু the voltmeter does a math, the red minus black. তাহলে আমার কি করবে? 20 minus 60 করবে. So how much should that be? Minus 40 volts, okay? এইটা যদি তোমাদের কোনো সময় voltmeter show করে negative, I think we talked about this the other day. It means that either your terminals are reversed or the first wire is at a higher potential, okay? BF কি হবে? Yes. And এটা I want you to keep in mind. It's something very important, okay? আমাদের পরে একটা সার্কিট করবো আমরা, call this stopping potential circuit or null region circuit বলা হয়. ওইখানে এটা খুবই ইম্পর্টেন্ট একটা পয়েন্ট যে listen to this, okay? আমি যদি এখান থেকে এখানে একটা ওয়্যার কানেক্ট করি, can you tell me how much current will flow through that wire? না না, এই যে এখান থেকে 20 থেকে 20 যদি আমি একটা তার কানেক্ট করি, right? How much current will flow? 3. How much current will flow from B to F? B to F. The answer is 0. And the answer is 0 because B potential koto? 20. F potential koto? 20. You're basically connecting, right? 2 points, 2 wires where there's no excess energy on either side. Charge flow করার জন্য একটা must, number one requirement is there must be a what? Like, you know, if you go to the foundation of electricity, right? The reason charges flow is because there's what? Potential difference. Potential difference না থাকলে কোনদিন charge move করবে না. Okay, there's no reason. A potential difference থাকা মানে একটা plus আর একটা minus, right? তাহলে একটা difference থাকলে there's a force, right? দুটাই plus থাকলে will charge flow like the same amount of plus থাকলে. So plus 20 or plus 20 থাকা মানে what's the difference in them? 0. So there's nothing to push the charge around. Okay, so এখানে কোনো charge flow করে না. এই ওয়্যারটার মধ্যে current 0 থাকে. Okay, somebody wanted FE hour. FE টা একটু explain করি. FE হচ্ছে FE is where is FE? Yeah, so F is at 20 and E is at 60. So when you do VFE, it essentially means V of F minus V of E. My potential of F minus potential of E, or it minus 40 volts. Okay. Can you tell me what's AG? 100 volts. And can you tell me what's CG? 0 volts. Okay. So আমি এখন তোমাদেরকে অ্যানালজিটা বুঝাই. The analogy of why potential difference, resistor, current, এগুলো সব কোথা থেকে আসে, okay? And that's my way to start the next topic, which is resistance. Okay, so আমি একটা example দেখাই. I have already discussed with you the analogy of what? The buckets. I have talked about the buckets, right? Eta is, I think, a little more practical in a circuit, okay? So imagine you have a ramp like this, right? And you have a ball that's here. A ball is an analogy for charge, okay? So a ball তোমার charge represent করে in your circuit. And এখানে বলটাকে একটা হাইটে নেওয়া হচ্ছে. So as you take the ball to a height, right, what does the ball gain? Gravitational what energy? Potential energy, right? So GP. This is basically the electrical energy you're providing, or more importantly, this is the watt of your circuit, voltage. Okay, so যখন আমরা voltage refer করি, এটার সাথে link হবে, চার্জটা হচ্ছে the ball here. The charge means the ball here, and this ramp that you see is essentially the wire of your circuit. Okay, so this ramp, this is the wire of your circuit. Acha, এখন tell me something, and it's part of your mechanics chapter as well. As I release the ball here, right, what does the ball do? Yeah, it goes down the slope, right? Because it loses what energy? GP, and what does it gain? Ke, right? Acha, ballta porlo ekhane. Ballta je rate pore is going to be analogy of what? Yes, and that is what? Current. বুঝছো জিনিসটা? আচ্ছা, এখন let me explain to you the logic here. Like, how are we going to use this to explain a circuit? We know there's a formula V equals to IR, right? ওইখানে voltage বাড়ালে কি বাড়ে? Current বাড়ে। কেন? Like, when you increase voltage, why does the current increase, right? So it's the same analogy here. When you increase voltage, what are you increasing in your circuit? The height. So এখানে যখন হাইটটা বাড়ায়, though, isn't there more energy? And if there's more energy, as the charge falls and falls, right, doesn't it gain more energy? So that's why যখন voltage বাড়ানো হয়, circuit কি বেড়ে যায়? Current বেড়ে যায়. It's actually the same analogy. So circuit এর মধ্যে instead of raising height, আমরা কি বাড়াই দেই? ব্যাটারির potential, মানে ব্যাটারি কত রিপেল করতে পারে। আর ব্যাটারি যদি বেশি রিপেল করতে পারে, what would be the speed of the charges moving? Faster. And if the speed of the charges moving are faster, what increases? Current. Do you understand? They can potential বাড়লে, মানে V বাড়লে can current বাড়ে, height বাড়লে কেন ball faster যায়, more energy, right? Okay, now where does resistance come here in to play the role, right? So can you tell me, আমি কিছু চেঞ্জ করলাম না, height চেঞ্জ করলাম, কিছু চেঞ্জ করলাম না, I decide to, you know, cover this ramp that you see here with a very thick carpet. এখানে carpet দিয়ে দিলাম, আমি আর কিছু চেঞ্জ করলাম না কিন্তু, I just use a much thicker carpet. Can you tell me, by using a thicker carpet here, right, as the ball is allowed to fall, what changes? Yeah, ball will be faster or slower? Slower, right? So আমি যদি resistance বাড়াই দেই, মানে friction বাড়াই দেই, তাহলে ball speed কমে যায় না? Circuit exactly same thing happens. If you make the pathway more resistive, right, what happens to the current? Decreases. For the same what though? Voltage. See, I'm using the same voltage. I have not changed my voltage, right? But I'm কি করছি, the path that my charges flow through, ওটাকে কি করে ফেললাম একটু rough, right? And as I make it rough, what happens to the charge? It flows slowly. Isn't that what happens in a circuit? V যদি same থাকে, R বাড়াই দিলে I কি হয়? কমে যায়. Clear about that? So this basically is a way of remembering what actually happens in a circuit. Okay, so circuit A, the potential is how much energy you're providing. Think of the charge being dropped from a height, right? The higher the height you have, the more what would your charge have? Speed, which means more current would be there. বুঝছো জিনিসটা? So the potential যেটা বলি আমরা, potential is basically যে how much energy it has at a given point. So বলটা যদি পড়তে পড়তে এই জায়গায় এসে থামে, right? What happened to the energy I had provided? Is it same or is it less? Less. So যে আমাদের 100টা একটা রেজিস্টার ভিতর দিয়ে পার করার পরে what was it, 60? So এরকম করতে করতে, when the charge reaches the bottom here, which is the other terminal of the battery, right, what should the potential energy be here? What should the potential be in your circuit? Is zero as well. That's the bullshit. Now, whenever the charges come back to the battery, what is the potential all the time? Zero. Do you understand what I'm trying to say? So that's the logic behind it, because it comes to the ground state when some energy used, which is zero, and then you come back to the circuit again, right? So anyways, it usually helps a logic ta bujhanor jonno. So future আমরা যখন হচ্ছে circuit করব, MCQ করব, maybe it'll help you out better. Okay, so yeah, we're done with potential. I'll do like a quick checklist of what we have done here. আমাদের ওগুলা সব শেষ। So আজকে resistance, তারপর হচ্ছে এই বাকিগুলো করব। Okay, so let's start. Can you go to page number 86 এর পাশে blank page টা। So we'll be doing everything related to resistance. Right. So the first thing we'll be looking into is something called the ohmic conductor. So everything that you need to know about the ohmic conductor. Let's see. Yes, sir. Right. So let's see what the ohmic conductor is. So এটা কোথা থেকে আসে, the whole idea of an ohmic conductor? So imagine you have a circuit here, and your battery here is a variable power supply. মানে তুমি হচ্ছে voltage ইচ্ছা মতন change করতে পারবা. And then you have your resistor here, which is a fixed resistor. And what you're going to do here is change the voltage across your fixed resistor and find the corresponding current change. Okay, so it's an experiment that we're going to do here. The voltage barely current increase. So see. So you place your ammeter here, and across your resistor you place your voltmeter. So this is your voltmeter. Right. So what happens if I change my voltage to current? And I already addressed this with something learning all levels. So somebody decides what a graph of this. It's a UMI. And you got a graph here for electricity. And you need to provide this for one graph. On short one, normally graph takes y plus x minus x plus y minus y, right? Do you know why? Why do we draw a four-quadrant graph when it comes to electricity? Right. So voltage and current can be both plus and minus, right? And voltage and current plus and minus, in some scenarios, right, the behavior doesn't change. In some scenarios, plus and minus behavior change. And the only component you have in your syllabus that actually changes behavior when you make your voltage plus to minus or vice versa is something called the diode. Have you heard of the diode? So diode that normally graph গুলো করতে হয়. Anyways, the voltage থাকবে x axis এ, current থাকবে y axis এ. Do you know why voltage is on the x axis? Yeah, it is the independent variable, right? Isn't it the one that we are changing? So once we do this, right, listen very carefully. Once we do this, we find that the graph for current versus voltage turns out to be a what graph? কিরকম হয় গ্রাফটা? এই যে voltage আর current এর variationটা কিরকম দেখতে হয় বলতে পারবা? Yeah, directly proportional, a straight line passing to the origin, right? It isn't though. Okay, so unfortunate. So তোমরা যখন গ্রাফ প্লট করবে তোমরা দেখবে গ্রাফটা হচ্ছে এই এরকম হয়ে যাচ্ছে, একটু যাচ্ছে এই যে এরকম হয়ে যাচ্ছে. There's a what to your line, there's a curvature to your line, right? Which means that the relationship is not what, directly proportional. So কেন এটা হচ্ছে? Yeah, it's because the temperature is changing, right? But if we made sure the temperature did not change somehow, right? তখন what will we find? A perfect straight line passing to the origin, right? And that is what Ohm's law is. Ohm's law states that voltage and current are directly proportional, provided that what remains constant? Temperature remains constant, okay? Is that the reality though? Whenever you're working with a circuit, does the temperature remain constant? No, right? So আমরা যখন Ohm's law apply করি V equals to IR, are we doing the right thing? No, it's actually wrong. আচ্ছা, আমি যদি আমার টিভিতে হচ্ছে কারেন্ট পাস করতেছে, I want to find that. I know the resistance of everything in my TV, right? V equals to IR যদি apply করি, it's going to give me a wrong answer. Why is that so? Because the TV heats up, and as the TV heats up, what changes for the TV? The resistance, right? And if the resistance changes, what happens to the value? It changes, right? Unfortunately, and fortunately for you guys, right? The thing that actually helps you find resistance at different temperature is a very complicated graph and a very, very complicated equation. যেখানে তোমরা একটা table দেখে হচ্ছে কাজ করতে হয়. It's so complicated that unless you go into electrical engineering, right, you will never hear about it. So the point is, যেহেতু এটা করা possible না, আমরা কি electricity পড়বো না? We will, but we'll assume something. We'll assume that every component that we work with in a circuit, right, is a what component? It's an ohmic conductor. মানে or resistance কি থাকে? Constant, right? And because it's an ohmic conductor, I will then be able to use an equation that helps me solve my circuits. What is it? V equals to IR, okay? So it's all based on a very important premise and an assumption that the components have constant temperature, okay? G constant temperature না থাকে, we do not do quantitative analysis, but আমরা math করি না, আমরা describe করি, যেটা আমাদের করতে হবে, eventually করবো, okay? So yeah, this is the graph here. Can anyone tell me what does the gradient of this graph give us? No, কেমনে resistance? কি বলতেছে এসব? Resistance can দেবে. Yeah, it'll give us 1 by R. Okay, be careful. The gradient of this graph is not V by I. The gradient of this graph is what? Right, I by V. And because it's I by V, it gives you 1 by R. So be always aware of that. Otherwise, mistake হবে, okay? Right, so this is your Ohm's law. Ohm's law আমি লিখে দিচ্ছি, and definition and everything দিয়ে দিচ্ছি, but তোমরা কি বুঝছো what I'm trying to do here? This is done at constant temperature. Now here's the thing, তোমরা practically যখন সার্কিট করবা ল্যাবে, right, রেজিস্টার গুলো কি গরম হয়? অনেক গরম হয়, and if you're not actually setting them up with the right values, right, it can heat up a lot. They can like start smoking, মানে একদম হচ্ছে ধোঁয়া বের হওয়া start করবে, আচ্ছা, happens, okay? So because our কাজ করবে? No, not even close, right? So you can't use that, but then you use that and they got more value match for it, okay? And that's not the fault of the circuit or V equals to IR. It's your fault. Why do you use V equals to IR, right? So how do you fix this, তাহলে? মানে তুমি যে সার্কিট ইউজ করতেছো, তোমার সার্কিট যে ওভারহিট হয়ে যাচ্ছে, how do you fix this? If there's in water, I mean, if you want to cool it down, yes, why not? But is there an easier way out there? Yeah, the thing is, practical করার সময় হচ্ছে or practical করার সময় you come across this thing electricity তে is do not keep your circuit what on. আচ্ছা, পুরো experiment just avoid turning on the circuit. I know it's very tempting to see what's going on, right? অনই করবা না, যখন রিডিং নিবা তখন কি করবা? It's like ওই যে পেশেন্ট থেকে রিভাইভ করার জন্য ডিফিব্রিলেটর ইউজ করে না, চাপ দিয়ে তারপর রিডিং নেয়, ওরকম করতে হবে. It's something like that. So you just put the two junctions, take the reading and open it, right? What do you prevent the circuit from becoming? Heated up. So তখন দেখবে answers are nice. Otherwise, if you keep them on, battery কমতেছে, heat বাড়তেছে, resistance change হয়ে যাচ্ছে, it's a new circuit a minute later. সবকিছু change. আচ্ছা, so yeah, just make sure you do that. The water part, placing in the water is actually something you do if you want to plot this graph, where you want to keep increasing your voltage and current, but you want to also maintain what? Temperature, okay? Water bad mein korte hai. Nah, so it's a myth that when you have electricity or a wire passing through water, it causes short circuit. It doesn't actually, because the electricity has two options: to go through water or to go through the wire, which is like an excellent conductor, right? So it never even prefers the water because water is not a good conductor. When does short circuit happen? When you have a terminal here and a terminal there, they're separated, nothing in between. And what do you pour in between? Water. তখন what does the electricity prefer? Because that's one option nai, the water, and that's when short circuit happens. So So short circuit happens when there's no alternate and water is the only path of going through. Okay. Right, so this is the Ohm's law definition and everything দিয়ে দিচ্ছি একটু copy করে নিও। আচ্ছা, একটা ইম্পর্টেন্ট পয়েন্ট হচ্ছে এখানে দেখাতে চাই, এটা নিয়ে কোয়েশ্চেন পাস পেপারে আসেন, স্টুডেন্টস স্ট্রাগল, সো আই থিংক এখনই বলে দিই তোমাদেরকে। ওইটা হচ্ছে you're given a graph here, আচ্ছা, and it's a IV graph, current here and voltage there, and the graph looks something like this. Sorry, এরকম দেখতে, okay? So you need to figure out you need to figure out which point here, right, gives you the highest resistance. Okay, so I'll give you some points here. একটা হচ্ছে A, একটা হচ্ছে B, একটা হচ্ছে C, and there's the D there, right? So how would you find the highest resistance? Or I'll rephrase it and make it easy for you. Find the resistance at D. So D the resistance বের করার জন্য কেমনে বের করবা? Tell me the process. I want to hear it. কি করবা? Draw tangent, right? And অন্যরা কেউ অন্য কিছু যদি করতে চায় আমাকে বলো। আচ্ছা, tangent মানে যেটা, right? Then what do I do? Gradient, right? So change in y by change in x. So যে এটা করব, change in y by change in x. বুঝছো জিনিসটা? So will that give me my resistance though? No, what will that give me? Oh yeah, so what I'll do is I'll do here gradient, which is v by I, I by v, so that's 1 by r. Tapor, you know, I can find r using what? 1 by gradient. Are you with me so far? Clear? This is wrong. Okay, এটা করলে 0 পাবো exam এ. So my question is, how do you find resistance at D? Interesting একটা জিনিস, it's an exceptional case here. And I know everyone would do the gradient because that's what we have been taught, that you know, gradient of the graph is resistance, right? But এটা করা যায় না, unfortunately. And there are a couple of MCQs যেখানে দেখবা যে ওরা যে ভ্যালুটা দিচ্ছে আর তুমি gradient বের করে যে ভ্যালুটা পাচ্ছ, they're not the same. Okay, so তখন students get confused. So I wanted to address this right now because the question আসে না আসে while we practice, I don't know. So বলে রাখি, use the equation and differentiate. No. Use the points as like the coordinates of D and use V equals to, yes, okay. You cannot find the gradient of a graph, IV graph, and find resistance. তোমাদেরকে কি করতে হয় সবসময়? V equals to IR use করতে হয়. So what you're supposed to do here is this, and I'll explain the logic behind it, don't worry. So তোমরা যেটা করবা, এটা তো একটা সার্কিটে কোন একটা পয়েন্টে এই ভোল্টেজ এই কারেন্ট যাচ্ছিল, right? Do you agree? So if this voltage and current was actually going through my circuit, ওই পয়েন্টে I'll just use V equals to IR, and R would be that particular voltage by that particular watt current. Okay, and that's how you get your answer, and you'll find it's not the gradient, it's a little different. Okay, now what's the logic behind this? The mathematical logic, the কেন gradient আর এই ভ্যালুটা different আসবে. So I'm going to explain জিনিসটা. What did I use here? The equation to find my answer, V equals to IR. Do you guys remember V equals to IR was based on what assumption? Yes, but ওই যে গ্রাফটা কিরকম দেখতে ছিল, straight line passing to the origin, right? This value is basically finding gradient, taking what as the starting point? 0 and 0. So do you know এই equation টা আমাকে কিসের answer দিচ্ছে? এই অ্যান্সারটা দিচ্ছে। এই যে আমি যদি এই ব্লু লাইনটা ড্র করি, এই ব্লু লাইনের যে গ্রেডিয়েন্টটা আসবে ইজ অ্যাকচুয়ালি গোইং টু বি দিস ভ্যালু। বুঝছো লজিকটা কি? আমি বলি v equals to ir কিন্তু হচ্ছে is derived from where? A straight line passing to the origin. So when I'm applying v equals to ir, am I not assuming the first coordinate of my graph is 0, 0, and this is the second coordinate, which is v, comma I, right? So the graph is assuming it's a straight line passing to the origin to that point when you use v equals to ir. বুঝছো? And if you look at the two lines I've drawn, the blue one and the tangent you guys drew, right, are the same steepness? No, right? আর এক্সামে এই প্রবলেমটাই হয়, that ওরা যে ভ্যালুগুলো দিবে দেখবা যে তোমারটা ম্যাচ করে উইথ দ্য গ্রেডিয়েন্ট, ওরা আবার এই ব্লু লাইনের ভ্যালুটা দিবে। দ্যাটস হোয়াই স্টুডেন্ট গেটস কনফিউজ, লাইক আমার গ্রেডিয়েন্ট ম্যাচ করে না কেন? বিকজ তুমি যেটা গ্রেডিয়েন্ট বের করতেছ ইজ নট v equals to ir. Do you see what that line is actually? It's actually a line with some kind of y-intercept out there, and it's not a way in Ohm's law, right? So that's why কাজ করে না. So the safest way here is just use what all the time when you want to find resistance, the formula, not the gradient. Okay, this is one exception out there. Anyways, আমি একটু নোটস দিচ্ছি, যা বুঝলাম ওগুলা একটু কপি করে নাও। তো ন্যাচারালি হচ্ছে জাস্ট গ্রেডিয়েন্ট বের করলে হবে বা ফর্মুলা ইউজ করলে হবে। Right, so Ohm's law. Ohm's law is something they ask quite often. Also, have you guys noticed that every question comes with a definition or an equation at the start? Right, so তোমাদের এমনি তো paper 2 is not like the more challenging one, but paper 2 তে তোমাদের প্রত্যেকটা কোয়েশ্চেনের মধ্যে there'll be like 1 to 2 marks definition, right? Things that you have heard before, right? Before you went to the exam, you get around 10 questions, so about 20 marks কিন্তু হচ্ছে just পড়লে পারবা, you know, you don't need to think, just remember করতে হবে 20 marks, that's a lot, okay? আর তোমাদের paper 60 তে যদি হয়, how much more do you need for an A? Do you know what's the A for a paper 2 paper? 45 থেকে I've seen maximum হচ্ছে 48. So 45 থেকে 48 এর মধ্যে যদি পাও, you get an A, right? So তার মানে you need to get only 24 marks more if you want to get an A, other than the definitions, okay? Which I don't really think is a lot. মানে প্রত্যেকটা কোয়েশ্চেনে 2 marks. That's not a big ask, right? So how do you planning to করো? I think it will be safer. So তোমরা যেটা করবা, once you're done with the syllabus, we're almost done. I mean 90% done. আগের টপিক গুলোর definitions গুলো সব scour করা start করো. Go through every topic, everything. Just like make a sheet with every definition, every equation that you can, right? তাহলে তো 20 marks ready. That's it. এর বাইরে তো জিজ্ঞেস করবে না ওরা। So এটা আগে যদি সেট হয়ে যায়, rest exam-এ আসবেন। I know a lot of things পারবা তোমরা. So it's very manageable, what I'm trying to say. MCQ, on the other hand, you have to be actually good. এখানে কোনো শর্টকাট নাই, ওকে? সো এমসিকিউটা প্র্যাকটিস বেশি করো। voltage, I think safer হবে potential difference লেখা, because what all levels of A levels of potential difference more preferred. So it says that the potential difference and current are directly proportional provided that the temperature remains constant. Do you ever get negative voltage in experiments? No, you get a negative voltage if your terminals are, you know, the other way around, which doesn't really mean it's a wrong answer. So not to worry.
Should we put a warning there only for straight line, which is gradient one line?
They do. Which method? You get the right answer. Because it is that you find resistance usually from the decodifier, right? And decodifier is the assumption that you graph something origin, right? But if you get this tangent that I've drawn here, right? And keep extending this, right? That's actually pass the origin. No, right? That's the decodifier formula.
On PDF.
Yeah, working on that too. Right. So next class I'll be doing filament lamp, thermistor, and the idea of resistance resistivity ratio. Okay.
So for the double slit experiments, is there any way to change the intensity of the fringes?